welcome, lovely people. Good of you to join us today. We'll be doing a little webinar, or we have been doing a series of webinars so far. Today on the schedule is assessing barriers or assessing controls in your critical control management program, for example. We'll do a little bit of a presentation. Of course, if you have any questions or if you're struggling with something and you would like to raise that, discuss it with the group, I think there should always be opportunities for that. So please feel free to either raise your hand in the application or just speak up. That's perfectly fine. You can do that. Just interrupt me throughout the presentation. That will be fine. I might tell you that I'll be covering that later in the presentation, so then we'll move on. But otherwise, you can also keep your questions to the end, whatever it feels more comfortable to you. You can also write something in the chat. And Isaac, if I may ask you to keep an eye on the chat and alert me if anything happens, because sometimes I don't have my eyes on every single window in the screen. A bit of a cough today, so if I'll be coughing, I'll try to mute myself, not to blow up your earphones, but just be aware of that. And I do apologize in advance for it. Let's share my screen so you can actually see what's going on. Good. Is my screen visible? And then the slideshow presumably too. Excellent. Great. So let's get started with this. So as I mentioned, we'll be focusing on the assessing of the critical controls in the critical control management process. If you have been part of the webinars in previous sessions, then we've already discussed a little bit of the overview of what critical control management tries to do. In a nutshell, it's sort of this kind of a life cycle, as you can see it on the screen right now. So it typically starts with some form of a risk identification process. So what are my risks? Which of these risks would I like to include in critical control management? Then typically we analyze those risks in more detail, and we often use bow ties for that, although you can also use other methods, of course. But the main idea is that we want to identify the different scenarios that can cause us to lose control over a particular risk, or how we can lose control over an activity that we're doing, and then specifically identify the controls that safeguard us against those situations. Now, typically, if we are creating this bow tie, we might end up having maybe 40, 50 controls on an entire diagram like that. So that's quite a lot. So typically what most organizations do is try to identify which of those controls are really the most essential, like the really key controls or the critical controls in that process. And then if you are very selective, you typically end up maybe having 2, 3, maybe 4 of those critical controls in your bow tie. And the idea is that once those critical controls are well under control, we have a pretty good grip on that, that information, on that risk. And then we can also maybe actively try to monitor those controls. But in order to monitor those controls or measure those controls or basically assess those controls, we first have to have a definition of that control. So what do we actually mean by it? Because if we don't have a good understanding of the definition of that control, it becomes very difficult to measure, because what are you measuring in that case? So the critical control definition. After that, we go into the measurement of that control. We evaluate that control. So when the measurements come in, we subject it to some form of an analysis, or we decide with a group of experts, like, what does this mean for us? Do we want to do something about this? Should we improve this control? And if we decide to do that, then of course we can decide to improve that control, maybe fortify it, or we can also come to the conclusion that we actually don't need this control at all, and we should actually remove it and to free up resources for other controls that might be more important. And after that, we continue into that loop again, so that we continuously measure, evaluate, and improve if necessary. For this talk, so we'll be focusing mainly on the center part here, where we define what the control is and measure the control. The other stuff, of course, is also interesting, but yeah, we have to scope the session somehow, and this is the current topic of discussion. Even these two notes are quite a large topic in and of itself, so I had to condense it a little bit and try to make it as practical as possible. So what I try to do is design this presentation a little bit around these 4 questions. So when should we measure our controls? Like, at what point in the life cycle of your control should you be measuring it? should you always be measuring it when you're executing it, or is it also okay to measure them a little bit after that, or like retroactively, like look at the control and see how it performed? Or, for example, should you always measure the control even before you start executing, so you can make sure that the control is in place when you actually need it? That's an interesting perspective, I think, when it comes to measuring. So we'll look at that. We'll also look at what to measure, because a control can be quite a large cluster of activities that need to happen simultaneously or in coordination with each other. So how do you decide what we should measure in a control? We'll dig a little bit deeper into that. Then, of course, there's also a question of how we will measure it. So what kind of data do we want to collect on our controls? There's, of course, all kinds of different options there. Every control, in a way, is unique. So therefore, also usually the measurements of those controls can also be unique, but they don't necessarily have to be. So we'll look at some of the options there, and perhaps you have some practical takeaways there as well. And then the last question, but not least for sure, is should we actually measure these things? Should we measure all the controls in our at our disposal or not? So like just deciding which controls to measure is quite an important one, because you can with critical control management or measuring controls, I mean, you can open a door to endless measurements basically, which is something we would try to avoid. So we want to be selective. So how do we decide when to measure something and when it is also okay not to measure something? So those are the four main questions that I wanted to dive into today. That's definitely not everything that you can, not every perspective that you can take when measuring controls, but it's a start, and we have to start somewhere. So first one. Oh yeah, but before I guess we go into this, it's good to sort of take a step back and think about what the goals are for our control measurement or control assessment, basically. And I think overall, if we're doing something with risk management or with safety management of some sort, the overall goal, in my opinion, should usually always be trying to create a safer organization. So an organization that is safer to operate in, which hopefully will translate in fewer incidents, for example. But yeah, a safer organization in general. I mean, we can dig into this definition of what actually safe really means, but I think just in general, people have an intuitive understanding that a safer organization is probably good to work in. And if that's the overall goal, well, then there's different ways, different goals, sub-goals, basically, that we can take for assessing our control. So one of them could be, we want to assess our controls because we want to improve the control performance over time. So over the course of the next couple of years, we want to see an improvement in how well our controls are functioning. And in order to measure how well our controls are functioning, we have to measure those controls and compare the results, of course, over time. So we want to see hopefully a progression or an improvement. So that can be one goal that we have. Another one would be to ensure that controls are always in place before work starts. That's a little bit more challenging, perhaps, but it can definitely be done. So that idea is, of course, that if we want to limit incidents, ideally, we want to make sure that every time we do a certain operation or a certain activity, then we want to make sure that before we commence, that all the controls, or at least the critical controls should be in place straight away. That's also a goal, but it's of course slightly different than the first one. And both of them you can set both of these goals, but it will probably affect the way you should assess your controls. And we'll take a little bit of a look at what the implications of that are. And then the third one can also be interesting, is more in the sense of operational decision making. So if we know what the current status of our controls are, then we can perhaps decide to proceed with an operation or maybe hold back on an operation. So if we know that some of our controls are impaired, then we can use that information to decide, should we now be doing this operation or should we maybe postpone it a little bit? So if we know that not all of our controls are working as well as we would like, do we want to send this person up on that scaffold to work at height, for example? Or do we want to operate in this manner at this time? In order to make those decisions, you also have to have barrier assessment information or data on the performance of those controls. But it might be slightly different again. So even though these are three goals that we can set ourselves for assessing controls, each of these goals will require probably slightly different types of information. And I'll try to sort of keep that in mind as we go through the presentation. Does that make sense so far? If not, feel free to speak up. Otherwise, I'll just move on. Yeah, so the main takeaway of this slide, I would say, is think about what do we really want to achieve with our measurement of our controls, because it will influence the way we should measure them and what kind of data we're collecting. So as I mentioned before, like in this little graph, this presentation assumes that you've already made your bow tie and you already know what your critical controls are. So we are already at the point where a assessment has been made on your risk, where you know what the scenarios are, you know what the controls are, and you've even already highlighted some of these controls that you feel are critical. So this image, for example, the dark purple ones would be considered the critical ones probably. I think we had a previous webinar where we focused a little bit more on that aspect. So how do you identify what is critical? But at this stage, we assume that it is done. So then the first question was like, when in the barrier's life cycle do we want to measure our controls? And to try to make that practical, I thought of envisioning it like this. So here we have this little block represents the control in the moment it is needed. And then you have sort of a time span in front and behind it. So this is the moment in time this control is being executed, and then there's a little bit of a time period afterwards and a little time before it. And anywhere on this timeline, we can try to measure the performance of this particular control. And you can imagine that for most of these controls will be, of course, be repeated very often. So rather than thinking of a straight line, it can actually be a sort of a loop. Like, for example, if we're doing working at height, there are controls there. And every time we go working at height, we have to go through this timeline again. So it repeats itself, of course. So there's a couple of different options there, I would say. All of these are, I think, in a way valid, but they have implications if you go for them. So one option might be, for example, to try to measure it as it is being executed. So maybe we can gather data while the control is active or while the control is being used. The nice thing about it is if we focus very closely on the control itself, is that we can capture very accurate data. So if we would have, for example, sensors checking if the control is working or not, well, that can give us very direct information on whatever the control is being used or not. But the difficulty with sometimes doing this is that, well, it's not always possible. And by introducing measurements during the execution of the task, we can sometimes introduce additional workload on people that should be focusing on actually doing the tasks rather than measuring the safety mechanisms. So typically, if we want to measure something during the execution, we're limited to the types of measurements that don't require too much human intervention. Like if we're out working at height, let's say we're dangling somewhere on the scaffold, we don't want to be filling out any checklists, obviously. So those kinds of measurements obviously would be out of the window, but there's typically other types of data that we can capture perhaps in that sense. So if we had sensor data, for example, that doesn't require you to fill out forms, that might be an option. But of course, not every control lends itself to that situation. You can also say, well, we want to measure it post execution. So after we've come down from the scaffold, then we can fill out perhaps a form, like how well do we feel that this was working. Again, this means that if you measure post execution, that means that we have to do it every time we do this. We have to fill out some kind of a measurement. And if we're again using a checklist or some kind of a form, that can be very tedious, especially if this kind of an activity happens quite often in an organization. If you have to do it once every day or maybe multiple times a day, then you can see that people will very quickly get fed up with this kind of assessment. So again, the more frequent probably we want to measure things, the more impact it will have on the the work that people will have to do, like the more time it will take away from their actual activity. So maybe in this case also we want to focus a little bit more closely on data collection that does not require a human input at that stage. Other people argue that we should always try to measure it pre execution, because that's the only moment where we can say, okay, we stop because the control is not yet in place. I think this typically works best for the types of controls that are more behavioral or require a human intervention, like let's say, for example, like wearing a fall rest harness when working at height. Yeah, you can check that pre-execution so that you make sure that every time we work at height, we have this kind of equipment on board. Again, because it's centered around this execution, it does mean that that these kind of checks will probably have to happen quite often if we want to go that route. But it is definitely an option. We can also take a slightly longer types of review cycle, so maybe every quarter or maybe even like every 2 years or something like this. If we do this, the execution has already happened. So we can't really take benefits from the measurement beforehand in this case, of course. But these kinds of measurements typically happen to try to improve the quality of the control over time. So these quarterly reviews or biannual reviews or 2-yearly reviews are still useful. But they will only benefit the goal that we had specified before, like the first one, try to improve the performance over time. For the second one, obviously, we would have to focus more on the moments in time beforehand. And for the operational decision making, again, we'll probably want to sit somewhere between post and quarterly review. So if you want to make operational decisions, the data has to be relatively fresh. It doesn't have to perhaps be fresh from second to second, but maybe from weekly to weekly basis, or maybe a monthly time interval is necessary. Otherwise, you're working with, 2 years old data, for example. It's not really going to be beneficial from a operational point of view. And even quarterly might be a little bit overdoing it. So maybe you're looking there at a weekly by weekly or monthly, for example, measurement, if you want to. But if you want to make sure that people wear it before they start to work, obviously we're more confined to the left-hand side of the control execution mode. Yeah, the preparation, yeah, it's in a way a bit similar to the ones that are further removed here. So we can perhaps try to look at preparatory activities that need to take place for the control to work. That might also be an option. However, the further we are, of course, removed from the actual execution point of the control, the wonkier the data typically becomes. Like after 2 years, can you still remember how the control was working 2 years before? I doubt it, for example. So the further you are removed, the poorer the quality typically of the data will become. But the nice thing about the longer cycles is that it has less of an impact on your workers, because you don't bother them every single time. You just take a moment, for example, every quarter, every month to check in how was this control working. So generally speaking, the closer you take the moment towards the point of execution, the more frequent you will have to measure these things, and the more of an impact you'll probably have on the work time people have to spend measuring these kind of things. If we're moving further away, then we typically do it more infrequently, which reduces the impact on the person executing the job, which can be efficient. So these are some of some consideration about when in the control's life cycle should we measure it. And again, all of these are valid options, I think. They will just produce different types of data that will be beneficial for different goals. So if your goal is to improve the control quality over time, then it can be perfectly fine to just measure it every quarter, and that's perfectly fine. If you want to make sure that the control is active every single time we do working at height, let's say, and then obviously you're tied into more of the pre-work or maybe during execution types of measurements. And that will impact the way you can measure these controls as well, because we don't want to bother people with endless questionnaires probably. I hope that's helpful. So think about when we're measuring the controls, like at what point in the life cycle of the control do we want to measure it, and how can that practically be done? Then of course the question is, what should we measure? So even if we decide on a point in time, we still need to figure out like what do we want to measure in that case, and it can often be easier said than done. Once we're identifying a control, it can be a very short description in a box of text, but there's actually quite a lot going on to make sure that the control is actually functioning out in the field. And one way to identify what we consider this control to be and identify what the requirements, for example, for this control might be, we have developed a little bit of a workflow or a little tool that I'd like to share with you right now. And it looks a bit like this. It's a bit of a chart. This is the empty chart. We'll look at an example in the next slide. But typically on top, you will write the name of the control. So for example, like your fall arrest harness or something like this. And then you'd also like to describe the control function. And that's basically what the control, like a description of what the control really aims to achieve. And we'll take a look at that, what that looks like in a minute. And then for each of the controls, we can break down the operational requirements. Those are basically the steps or the actions required on the day of execution. Okay, no problem. Thank you. See you next time. So the steps are required for the control to function on the day of execution. So let's say you arrive at the site. What steps need to happen on the best day, for example, for this control to work? So typically, if we do this with clients in workshops, we do a bit of a brainstorm, like on an ideal day when you have to work with this control, what would it look like? So then we can brainstorm. Okay, if well, first before we even arrive on the site, we probably want to know beforehand that we are going to do some kind of a work at height activity, for example. So then we know what kind of information to bring. Okay, well, then we can already start with that and move away all the way up to the end of the control where we're cleaning up and making sure that the materials are stored in the correct position and these kind of things. So those are the operational steps. Then from the technical point of view, we also want to identify the types of equipment and systems required for the functioning of this tool. So what kind of tools, for example, do you need to bring? What kind of technical requirements do these tools have? You can specify them as well. And lastly, and but not least, of course, the organizational bit, which typically focuses more on the roles and the functions and the competencies required for you to execute this. So how many people do you have to have in order to do this? What kind of competencies do these people need to have? What kind of information needs to be already sorted out beforehand, for example, so that when people arrive to implement this control, they have all the information and skills basically required to do the job. So let's take a look. We'll just use the fall arrest harness because I think that's quite a ubiquitous type of control that most people will be familiar with to some extent, at least. It's of course an example, right? So we're not going into too much detail, but we could say that the control is the use of the fall arrest harness or the fall arrest system. So we have a harness, we hook it up to something to make sure that if we fall, we don't hit the floor. And that's exactly what the control function tries to describe. So the use of the fall arrest system should prevent a person from hitting the floor or the structure after falling, for example. Maybe that's what we see that this thing needs to achieve. This already provides us with some information on how to measure this control. Like ideally, if we measure this control, we should be able to predict if this device will actually prevent this person from hitting the floor or the structure, for example. But since this is sometimes difficult to measure straight out of the bat, we also want to look at some of the requirements for the operational, the technical, and the organizational lens. So from an operational point of view, we might see something like this. So it's almost like a timeline. So at some point we receive the work order, we collect our gear. Before we put it on, we check our gear, then we proceed to putting it on. Then we hook it onto the structure, we execute the work, and then afterwards we check our gear and maybe return it to the position. Since my screen was this big, I left it to these 4 steps, but you can imagine that in real life you would be a little bit more minute in describing this. But this is an example. Well, those are the operational steps. So that's basically what needs to happen on the day of execution. Well, then there's also some technical parts related to it. Of course, there's the harness to think about. The harness needs to be in a good condition. But in order to retrieve the correct gear, probably the harness also probably needs to be equipped with some kind of a tag or a unique identifier, so we know who is wearing which harness, and keep track, for example, of the certification of such a harness. But other than the harness, of course, there's also the fixation points, because if we have a perfect harness, but we don't have a point to hook it onto, there's no real point, of course. So also this needs to be, from a technical point of view, needs to be in place. And then lastly, for the organizational point of view, yeah, there's other things we can think about. So probably you want to make sure that the gear is available in the correct sizes. So we need to make sure that we know, yeah, the sizes of the personnel working on that site, and they should be available and certified. We need to make sure that the person is available on site to do this check. So is everybody capable of doing that check? Are people trained in how to do that check? Are they trained in how to wear the harness, for example? All these competencies can be listed here. Oh, there's a duplication here. But also when returning the gear, for example, you can imagine that you might want to have somebody there to take in the equipment, maybe do an additional check, or at least store it in the correct facilities. So with a form like this, and typically we do this on a large whiteboard, for example, or a big wall with post-it notes, we try to really break apart this control and identify these different smaller requirements from the operational perspective, technical and organizational perspective. And every one of these little green cards on the board are potential hooks where we can identify some data points on, for example. It doesn't mean that we have to measure everything. It's just trying to, well, first of all, understand what this control is all about. So what kind of activities go on underneath the hood of this control. But then also, yeah, provides us maybe some options of things that we can measure. So if we can't measure, for example, the function of the control directly, then maybe we can measure some of these requirements. And if we see that one of these requirements is not being met, well, it tells us something, of course, on the quality of the control at that point. And it's always an eye opener, I find. Like if we do this, yeah, when you're making the bow tie, it can be just very simple to put these words in the box and say, okay, we have a fall arrest system for this risk. Everybody sort of understands what it means, so that's fine. But then when you dig a little bit deeper into it, you suddenly see, oh, there's actually quite a lot of activities and stuff that needs to happen for this fall arrest harness to really work. Yeah, and then it can be good for that. A similar system also works with, I guess, less active types of controls. So when we're thinking of, for example, like a bund wall, so this would be like a little dike around, like let's say a tank that holds oil. If that primary form of the tank, for example, fails, the oil will spill out. If we have a bund wall, it's quite a nice way of containing that spill into a particular area so that we can deal with it. So again, the function of that bund wall is to prevent fluid from reaching the environment after spilling out of its primary containment. It's quite an effective control, of course. Like even if the tank fails, we still are capable of containing it. But it's more of what we usually classify as a passive control. It doesn't require a direct human interaction, for example. It's just a wall that basically sits there. But even on these kind of things, we can still look at it from an operational, technical, and organizational point of view, although probably it will be slightly heavier on the technical aspects compared to the other ones. But yeah, probably we want to make sure that the wall of that bund wall is structurally integral so that it is indeed capable of containing the fluid. But typically, because we're building a bit of a dike, there needs to also be some kind of a drainage system, because if it rains, then we don't want all the rain to pile up in that. We eventually want to be able to spill it out to get rid of that rainwater. So there probably should also be a drain system. But at the same time, if there's a drain system, we also want to be able to close that drain system off so that if there is indeed an oil spill, that we don't drain all the oil away as we would with the rainwater. So again, there's some technical capability. So yeah, of course, the wall needs to be high enough so it can contain all the fluids and stuff like that. What we notice with these kind of more passive types of controls is that you typically don't want to measure that every single time, because it's just a wall. It will be sitting there probably for quite a long time. For example, there will not be any change to this wall. If you check this every day, you will get the same results probably for a very long time. So maybe it is okay to check these kinds of controls in a slightly longer types of cycle. So again, also when thinking about the life cycle or the execution of the control, the types of control can also dictate how often we should measure it. But again, yeah, it's fun to try to decompose a control and identify what kind of aspects are in it, so we can actually yeah, see what we can measure within the control as well. Of course, I mean, if we're measuring, well, breaking down these individual activities, we can measure those activities, of course, but there is a bit of a pitfall there, and that's basically is that the further you stray away from the actual barrier function, so the further we start measuring requirements or maybe even the supporting activities that need to make up that requirement, the further we are removed from the actual controls function. So we're starting to measure things that are more precursors to the functioning of the control, which is sometimes just easier to measure. So that's why we often do that. But it also becomes less and less predictive of the controls function the further we are removed from the actual control function. So typically, if we can measure the control function directly, like prevent a person from hitting the floor or structure after falling, then that should ideally be our focus of measurement. Unfortunately, that's not always possible. Like for example, with the fall rest harness, we can't go. I mean, I don't think it is a good idea to ask people to, can you please fall for me so I can check if your harness is working. That's probably not the best approach because we're exposing people to danger. But there are types of controls where you can actually do this. So for example, if we have a lifting crane, for example, there might be some kind of a software device which prevents you from extending the load too far outside of the reach of the arm, making the crane collapse, for example, because the pressures become too high. You can actually test directly if this control is working. You can just take a load, lift it a couple of centimeters above the ground, and then try to extend it as far as you can. And then at some point, this control device should kick in. If it doesn't, well, we know that the control has failed, so that's a good indication. And if it does work, okay, we have proved that the control is working without doing actual damage to the crane, and then we can start the operation. So if you can measure the control function directly, that's always the best, because then you're directly measuring it. But like I said, not all of these controls allow you to do this because it becomes just simply dangerous to try and actually test it real life. So in that case, it might be good to look at some of those requirements and say, okay, maybe we can measure some of these requirements. And if we know that these requirements are not there, we can also tell us something about that the controls might not be as effective as we would like. So for example, when we're checking the full rest harness, for example, we might be able to check, okay, is the harness in good condition? Are people wearing it correctly? These kinds of requirements. You can already see perhaps, or think about that this already poses some problems, but because if we're checking the harness and the harness is okay, it's not a foolproof guarantee that people will not hit the ground, because if they're not hooked up to a correct fixation point, or if the fixation point, for example, fails, the harness can still be in perfect shape, but it still will not provide the kind of risk reduction we're looking for. So that means that if we're doing requirement checks, we probably have to check quite a few requirements in order to come to a full, complete picture, if we really want that full control, complete picture. And that becomes even worse if we are looking at supporting activities. So the supporting activities would be all kinds of tasks we do to make sure that the requirements are being met, so that in the end the control works. Again, then we are even further removed from the actual control function, and then it becomes even more wonky. The thing is that usually these supporting activities are just easier to measure, because maybe we indeed have a certification regime and we can check the stamps and we can see that it is there. And that makes for very easy checking. But unfortunately, it's not always super predictive for the actual control function. So keep that in mind. So when you're trying to measure the control, always try to think about ways, can we really check the control function? If not, can we check the requirements? And if that's not the case, then we can maybe still check some of the supporting activities. But the further you are removed, the more careful you need to be about what is this data really telling me. Yeah, I hope that makes sense. Then a question about how to measure these kind of things. So what kind of measuring tricks can we do to come up with the barrier performance data? Well, we typically see these types of information being used. And this is definitely not a complete list, I would say, but this is generally the rough areas I feel that people come into. And all of these methods, I think, have their merits and downsides. So it's not like we should always choose one or the other. There are different benefits and downsides to these, and I'd like to quickly go over them. So we have opinion, operational. So opinion is basically just asking people, how do you feel this control has been working? Operational data would be more about sensor data, for example, or maybe some other type of log that we can assess. We have inspection data, and that's basically maybe a quick checklist or something like this that we can do, or a quick walk around where we check certain things. Incident data. So have these controls been working in the past, or have we seen incidents where they have not been working? And the last one is audits, which I see as slightly different than the inspection. So I think audits are usually lower frequency and also looking at more of the supporting activities often, rather than the inspections would be more on the work floor directly inspecting these items. Yeah, like I said, there might be more in here, but this is what I want to confine myself to. And I've created a little bit of a scorecard with a couple of characteristics and how these measurement types score on this scorecard. So the first one is opinion. And often people don't like this because like it's an opinion, like why yeah, they can be very inaccurate, right? So people can just say that they feel the control's working while actually it is not, for example. So is it useful? Well, I think it's an overly underlooked type of control. I think I quite like this one. Because the effort to set up a process to capture opinion is quite simple. Like in a lot of organizations, we can just create a MS form type of automated form and just send it out to people from time to time. You can ask a lot of different people how they feel this control is working. And if it's a control that people work with on a daily basis, for example, they have a very good understanding often of how this control is working. And since they are working with it every day, they also have all the reason to make sure that this control should be effective and easy to work with, for example. So it's relatively low effort to set up. The effort in operational use, what I mean by that is basically how intrusive the measurement is to people on the work floor. And this is, yeah, it can be a bit intrusive. Like if we do this after every job, for example, people get fed up with it very quickly. But typically, these opinions can often be gathered maybe on a quarterly basis. And if you just have to spend 1 minute of your time every quarter to check in on this control, it can be very simple. And I think the impact that it will have on people's time is still relatively low. If you do it very often, of course, it gets tedious. So you have to scale that a bit. It is also applicable to almost any control. So you can do this for anything. You can do it for bund walls if you want to, like, or you can do it for the harness. It usually works. The accuracy, of course, yeah, can be sometimes low, especially if people are incentivized to give off green readings, for example. But often what I find is that the accuracy is quite good. So if we're asking people, like people are genuinely often concerned with these kind of things and do actually report issues that otherwise would not have been found. And the specificity, it is quite nice because it captures often quite a broad perspective on this control. People can come up with anything that they want to say about it. They can mention it. We're not specifically asking about a specific part of the control. We're just asking about the general control in and of itself. What I often find is like most organizations, of course, have like some kind of a system in place where people can leave a safety report if they see something that's out of the ordinary. It is often quite a big hurdle to actually do this. So often people, I think, will see things that are out of the ordinary, but yeah, don't have the time or don't at that particular point in time have the time to write it down and actually put in a whole form. Whereas if we're actively going out to people and asking their opinion about this specific control, then they will often say, well, actually, last week I saw that these harnesses, for example, were they didn't fit. Like I didn't have a good harness and I just had to go to work, but it wasn't comfortable. It wasn't something that I would like to do. People don't often fill out like a full form for this at that point in time, but if we ask them later on, they still bring up this kind of information. And we actually, when we do this with clients, we often find very interesting and actionable items just through this means. But it's low effort and still has quite good results. Operational data is very interesting as well. So this would be, for example, sensor readings. And even for things like working at height, like the full rest harness, we have seen companies that use, for example, hooks or sensors in those hooks, so you can see actually where people attach it to, or if it has been attached, for example. So there are sensor data sometimes that we can get in here. I think nowadays with the Internet of Things type of applications, we see more and more sensor data coming online that we can perhaps make use of. It's typically very difficult, however, to set that up. Of course, like you have to install sensors everywhere. That's quite a big investment. But the upside, of course, is that once the sensors are there, you don't need any human input anymore. You can just read out those sensors. So that's a big plus. So if you do many frequent measurements, then there can be a very effective way to go. And sometimes the sensors are already there for other purposes, and then you can reuse the effort. Applicability, however, is quite low because there's only a handful of controls typically that really lend itself very well to these types of measurements, but it can be done. The accuracy is often pretty high. You can just get the numbers. You still need to interpret them, of course, but the accuracy should usually be good. But the specificity is that it's usually quite topical. Like the sensor is only measuring one particular thing. Like if we have a sensor in a hook where people hook it onto, for example, yeah, that tells us that people have been using that hook, but we don't know if that hook has ever been attached to a harness, for example. So yeah, we're only measuring this very specific thing, which is just the reality of these kinds of things, but can still be useful, of course. Inspections, like sometimes this can be done as a sort of a pre-shift type of inspection. Like before we start work, we do a quick round, check if all the critical controls are in place, and then we start to shift. That can be a way of doing it, or for example, before we start working on high voltage equipment, we want to make sure that at least some essential steps have been done, for example. So that could be a sort of a type of an inspection thing. It's a bit more effort to set up because you have to come up with a good way of measuring this, and maybe you create some kind of an app perhaps to get the data in here. And it's also typically quite high effort for the people on the work floor because there needs to be someone who does this check. It costs time every time. But yeah, it can be a very direct way of measuring, of course. The nice thing about it is, of course, it's applicable to most controls. It's quite high accuracy, and it can cover quite a broad range of aspects. So it can be quite a good tool, but I think it has to be used sparingly and effectively because it is quite impactful on the people working with it. Then we have, of course, incident statistics, which can, you can read the scorecard perhaps for yourself. So it's quite high to set up. I think like setting up a good incident analysis and doing a good analysis takes quite a lot of time. You have to have people that are skilled in doing that as well. It is quite applicable. It's usually quite high accuracy as well if you have enough time to spend on it. But of course, the downside is that it is all, of course, very retrospective. And also the data coming in is very incidental. So something has to go wrong in order for us to do an incident on it. And even if something went wrong, but just for sheer luck, it didn't result in an unwanted outcome, then we're usually not capturing that kind of information just by using incident statistics. So there are some downsides to it, but it also can lead to interesting insights. And the last thing is the audits, which is of course high effort to set up and relatively high for the operational, high often impact on the operation because people will have to take. I often have like visits with clients and they say, oh, well, there's an audit coming up and everybody is like super busy with the audit. All appointments are canceled. So you can see that it's usually quite impactful on the operation to do this. But the other, the upside of it is, of course, that it's quite broadly applicable and you can measure all kinds of things. But this is typically not something that you would want to do, obviously, on a daily basis. This is very low frequency type of stuff, but still useful. So these are these kind of things. So why do I bring this up? well, just to give you a bit of a showcase of what kind of measurements you can think of, but also to give you an idea that you don't have to like always go for operational data or always go for the inspections. You can choose whatever fits best for the types of control. And you can also say, well, maybe we want to start off with the low effort stuff that gives us maybe a little bit of insight, like an opinion type of thing. Is pretty straightforward to set up. And then if we feel that in the opinions we see that the reports are coming in that the control is not working as well as we would like, then we can decide to ramp up to more effortful types of investigations, because then you have also for the organization like you can demonstrate like, okay, we already see that this control, people have spoken up that this control is not working as well as we should. So perhaps it is warranted to take a little bit of a closer look, maybe by installing sensors, or maybe by putting in an inspection type of regime, which is a bit more intensive perhaps, but there is a good reason for doing it because, well, we see that it is problematic. So that's why I think it's always a good idea to start with the low-hanging fruit, like the opinion one, and then build your way up to more intensive regimes if needed. And for a lot of controls, it might never be needed. So we just use the opinions to periodically check in on it and only ramp up when we actually want it to be in place. So that's good to think about as well. You don't have to go all the way straight from the bat. You can just build your way up if needed. And it's also easier to get the organization along with you because, well, we already have some data that says that it's not okay. So maybe we should take a bit of a closer look. Or, for example, I often see like, yeah, well, this is just opinion data. So don't we have any hard data? Well, if they already say that themselves, then it's easier to go into that direction, of course. Well, then the last question, of course, should we measure all these things? Because any time of measurement, of course, costs time. Do we want to do this? And I think a practical way of looking at it is through this sort of a matrix, where there is a sort of a need for the data. So, like how badly do people want to know about the quality of this control, which can be low, medium, or high. So for example, if the people already feel that the control is probably working fine, we haven't seen any incidents with this, then probably the need to check this control is relatively low because people already feel that this control is working quite well. Whereas there might also be controls that are known problem areas, or people are really queasy about this. They have seen incidents with it, for example, or it is a new type of thing that they're doing and they're just not sure about it. Then the information need is quite high because people want to know how well this control is doing. And then we can set it off against another axis about the amount of effort that is required to obtain the data. So for some data, for some types of controls, the sensor data is already available. So there's very low effort to really get the data because we already know. Well, in that case, like going for active measurements is quite an easy step to take because it is very little effort. We can just get the data straight away. But there might also be, for example, the very high effort types of data to collect. So for example, it's just a very difficult control to measure actively. For example, yeah, we almost have to go out into the field with the clipboard to really start counting these kind of things. Super high effort. That's probably not something that we want to do for the if the data need is low, then and the amount of effort we have to put in to get the data, probably the answer should be no. Like we don't want to measure these controls in that case because it's just too impactful for the situation. Then there's of course also a bit of a gray area. And my advice usually is to start with those periodic types of checks in these kinds of cases. So then you can still, like, because it's periodic, like maybe every quarter or on a monthly basis, depending on what you want to do, you can still get some information on it. And based on that, you can then later decide to go into a more active measurements or more frequent measurements, or maybe decide not to measure it any further, or maybe reduce the frequency even further. So maybe a check once a year, for example. That still, yeah, keeps the measurement load manageable, I think. So you don't have to always go for active measurements. You can just play around with the frequency and fine tune it the way you think is best. Yeah. So some final conclusions and takeaways. I think we're almost at the end as well. So depending on your goal, infrequent measurements can still be valuable. So sometimes people think, okay, we're doing critical control management, which means that every time we do an operation, the control needs to be fully, perfectly in place. Otherwise, we don't start. That's, of course, one of the goals that you can set for yourself. But even if you measure more infrequently, you can still improve the control over time, and that can be an acceptable first step along that way. And I think that should be that's commendable as well, I would say. Try to measure the control as directly as possible. So what I mean there is to try to measure the control function, ideally directly if you can, and then move away from it if that's impossible. But like then look at the requirements and then the supporting activities. You want to have a good understanding of what the control is before you start measuring. So try to make such a control breakdown, for example, in the manner I shared with you today. And then the last one, take a pragmatic approach. So start measuring it in easy ways. So maybe just an opinion type of poll. And then you can always make it more complex later on and more frequent, for example, with more interesting measures. But to start off with, opinion is not a bad idea. And then you can just fine tune it as we go along. And then, of course, not everything has to be measured. So if it's super difficult to get the data and the control is just not that exciting anyway, then probably you don't want to measure it in the first place. And that's also okay to draw the conclusion. Yeah, that's as far as I wanted to take you today. A lot of information, I bet. I hope it was easy enough to follow. And yeah, if there's any questions, I'd be happy to take them. No questions forthcoming? Yeah. Hello, Iwo-kun. Nice to see you. So the question is from Iwo-kun is, what methods or strategies do you typically use to report, summarize results, and measure on critical controls? Good question. So since the topic of this presentation was mainly on the measurement part of it, we haven't really covered this evaluation part, which is basically like how do we present the resulting things. It depends a bit, I think, like how do you want to present the data that is incoming? It depends a bit on how frequently you're doing it. So if it's like a quarterly check with opinions, for example, then just making a PowerPoint presentation every quarter with the results might be perfectly fine. If you're doing it more frequently, like on a monthly basis or even more often, then maybe a dashboard becomes more suitable. So you can actually see trends over time, for example. So are the controls improving, going down? I think that's usually best done in a sort of a dashboard environment because the frequency of data updating is more logical. And yeah, depending on the client, we've done that, for example, in Power BI, where you have a generic dashboarding type of platform or Tableau or something like that. But yeah, like I said, in other ways, you can also just simply make a presentation that can also work. But if you have to do that every week, for example, then it gets old very quickly. So you want to have a more direct measurement of that, or like a direct way of displaying it in a dashboard. Does that? I hope that answers your question to some extent. And nice of you to join. Okay. Any further questions? Otherwise, I'd like to thank you very much for attending. I hope you enjoyed it. The recording will be published later, maybe today. I don't know, like at some point. And feel free to share it, of course, with your colleagues. Thank you for your attention today, and yeah, hope to see you with the next one.
Thank you very much, Jasper. Thanks.
Thank you.
Thank you, Bye.
Thank you, Sinead.
Bye-bye.